These are the notes for lesson 4.1, matrix operations. Chapter 4 is all about matrices, and matrices are just a way of organizing data. So a matrix is a rectangular arrangement of numbers in rows and columns. So again, if we have multiple different numbers representing different things, we can arrange them in a matrix that makes the data a little bit more organized, and then we can also do operations with those matrices once we have the data organized. We name matrices by their rows and their columns. So remember that rows are left to right, columns are up and down. So for instance, if we have a 3 by 2 matrix, that means that there are 3 rows and 2 columns. So again, it's rows by columns. So equal matrices are 2 matrices that are equal if and only if they have the same dimensions and the entries and corresponding positions are equal. And we're going to look at some examples of this. Our first matrix, part A, we see that we have 3 rows. So this is R1, R2, and R3. And we have 2 columns, so column 1 and column 2. So this is a 3 by 2 matrix. Again, 3 rows, 2 columns. Part B, again, row 1 and row 2, so we have 2 rows, column 1, column 2, column 3, and column 4. So this is a 2 by 4 matrix. And part C is what we call a square matrix because we have the same rows and same columns. So we have 1, row 2, and row 3, column 1, column 2, and column 3. So this is a 3 by 3 matrix. For example 1, are these matrices equal? Again, we are looking to see that they have the same number of rows and the same number of columns, and then checking the corresponding positions. So we have row 1 and row 2, column 1 and column 2. In the second matrix, we have row 1 and row 2, column 1 and column 2. So they are dimension-wise equal. We just need to make sure that what is inside the matrix is also equal as well. So again, let's start with our first one. We have 5.5, -1, and 3. Let's look at column 1, row 1 in our second matrix. We have 25 divided by 5, which we know is 5. We have 1/2, which we know is 0.5, -1, and then 6 divided by 2 we know is 3. So notice that every number in the corresponding spots is exactly the same, so these are equal matrices. For example 2, we're looking at adding and subtracting matrices. In order to add and subtract matrices, they must have the same dimensions. If they do not have the same dimensions, we cannot add or subtract them. So for part A, we have the matrix 2, 1, -3, and 4, plus 5, -3, 0, and 4. So notice we have a 2 by 2 plus a 2 by 2 matrix. So again, since they have the same dimensions, we can add them. So when we add matrices, we just add the corresponding positions. So we're going to start with 2. This is row 1, column 1. And row 1, column 1 for the second one as well. And we're just adding these together. So 2 plus 5. And then we can take row 1, column 2. So we have 1 and -3. Again, adding those together. Next one, we have -3 and 0. And lastly, we have 4 and 5. So we're just going to add these. So we have 2 plus 5, which is 7. -3 plus 0, which is -3. 1 plus -3, which is -2. And 4 plus 5, which is 9. So our answer is this matrix right here. So again, they have to have the same dimensions in order to add and subtract them, and then we just add or subtract the corresponding positions. For part B, notice that we are subtracting. Now before we do anything, it's easier to change the subtraction to addition and make everything the opposite. Remember that subtracting is the same as adding the opposite. So in order to keep our signs correct, the easiest thing to do is change this to addition, and then again change the sign of everything inside the matrix. So again, our 5's become negative, 0 is neither negative or positive, so we don't need to put anything there, and our -3 becomes a +3. So then we can add just like we did above. So we have 2 and negative 5. We have 1 plus 3, negative 3 plus 0, and 4 plus a negative 5. Again, then we just add these. So we have 2 plus negative 5, which is negative 3. 1 plus 3 is 4. Negative 3 plus 0 is negative 3. And 4 plus negative 5 is negative 1. So our answer is, again, this matrix right here. So again, whenever we're adding and subtracting matrices, they have to have the same dimensions. If they don't have the same dimensions, we cannot add them. Matrices can also be multiplied by a constant, and we call this scalar multiplication. So we simply take the number outside and multiply it by everything inside the matrix, just like we would with the distributive property. We're distributing the number out front by everything inside of the matrix. So with this first one, we are multiplying 5 times everything inside the matrix. So we have 5 times negative 1, 5 times 0, 5 times 2, and 5 times 8. 5 times negative 1 is negative 5. 5 times 0 is 0. 5 times 2 is 10. 5 times 8 is 40. So our final answer is this matrix right here. You can do the same with a fraction out front. Again, we're going to take 1/2 and multiply by everything inside the matrix. So 1/2 times negative 1. 1/2 times 0. 1/2 times 2. 1/2 times 8. So 1/2 times negative 1 is negative 1/2. 1/2 times 2 is 1. 1/2 times 0 is 0. Half of 8 is 4. So this is our final answer. So again, we just take the number out front, multiply times everything inside the matrix, just like we would with parentheses or any other operation. Example 4 says to solve the matrix equations. Again, in order to solve matrix equations, we must have the same dimensions. If we do not have the same dimensions, it's not possible to solve the matrix. So here, again, we're looking at corresponding spots in our matrix. So we first want to look at row 1, column 1. We have an x and we have a 2. So that tells us that x equals 2. Notice that column 2, we have 7 equals 7, which we know is true. And we have 4 equals 4, which we know is true. Then if we look at the last entry in our matrix, we have 2y equals 8. So if 2y equals 8, to solve for y, we just divide by 2, and y equals 4. So in this matrix, x equals 2, and y equals 4. Now for part B, we kind of are throwing everything together. So we want to think order of operations. What do we do first? We first want to do what's inside of the parentheses. So we first want to add the two matrices together. So if we have 8 plus 4, let's keep our 4 out front. So 8 plus 4 is 12. 0 plus negative 2x is just negative 2x. Negative 1 plus 1 is 0. And 2y plus 6 is just 2y plus 6. And this is still equal to 48, negative 48, 0, and 8. So now we're going to multiply 4 times everything inside the matrix. So 4 times 12 is 48. 4 times negative 2x is negative 8x. 4 times 0 is 0. 4 times 2y plus 6. Remember, we're multiplying times the quantity, so make sure you use your parentheses. And we could multiply this out to get 8y plus 24. Again, this is still equal to 48, negative 48, 0, and 8. So now we have to solve for our variables. So we first want to solve for x. So notice we have a negative 8x, and that's equal to negative 48. So we set those equal to each other. To solve for x, we know we divide by -8, and x equals 6. We also need to solve for y. So we have 8y plus 24 equals 8. We're going to subtract 24 from both sides. So we have 8y equals -16. Divide by 8, and y equals -2. So x is 6, y is -2. Now if we were to plug that back into our matrix, we would end up with this matrix right here. And lastly, example 5 says, given the following matrices, perform the following operations. So notice for part A, you are taking A plus B. So matrix A and adding that to matrix B. So if we have -1, 2, 6, and -10, we're adding that to -1, -2, 0, and 3. So I want you to take a couple minutes. I want you to pause the video. I want you to do part A where you're adding the matrices. I want you to try part B, remember of order of operations, so we're going to start with what's inside the parentheses and then multiply times 2. And then part C as well, remember we multiply first and then subtract. So I want you to try all 3 of these examples. I want you to see what answers you get, pause the video, and then once you play the video, you will see the answers so you can check them. So you should have answers for all 3 of these problems. Notice that the correct answers are outlined in black. So I want you to double check your answers and see what you got. Make sure that you got the correct ones. If you did not get the correct answers, I want you to go back through and find out where you made your mistake mathematically and make sure that you know how you get to the correct answer. And then tomorrow, if you have any other questions as to how you didn't get the right answer or how you got the answer, we'll go over that in class. So again, with matrices, you have to make sure that you have the same dimensions before you can add, subtract, or multiply by a constant.